Hello everybody, welcome to Methods. So today we have our square and circle problem. The statement of the problem says that Sina drew a square ABCD with a side length of 6 cm on a piece of paper and passed the paper to Theo. Theo drew a circle on top of the square so that the circle passes through this point A and point D, and the circle is tangent to the side BC. So this BC side is the tangent to the circle at point P. Okay, and this point P is known as point of tangency. So first of all, what is tangent? If you are not knowing, let me draw it. So say this is our circle. I'm drawing this line. Say this line, and say this line. Wait, this line. So the very first line that I draw, this line, this is not intersecting the circle at any point. So we say this line to be non-intersecting lines. Non-inter non-intersecting lines. This line is cutting the circle at the 2 points. So this is secant line. We call that type of line to be secant. And this the line which touches the circle at only one point, like this is the point P. So this is called a tangent, and the property of tangent is that this is the it is perpendicular, like the radius drawn at the point of tangency on the tangent is perpendicular to the tangent line. So this point is known as point of tangency. Point of tangency. Okay. You might have studied the chord in your lower grade. What is chord? And what is secant? What's the difference between a chord and a secant? So chord is basically a line segment, but secant is a line. Line means basically it will extend up to infinity on both directions. But chord is a line segment. This length is fixed. So this is the basic difference between a chord and a secant. Okay. Now we need to find the radius of the circle. So what we will be doing that? Let's suppose this is the center of the circle. Let's name it to be O. So if this is the center of the circle, so as from the property we can say that, sorry, yeah, this point will be the perpendicular to the BC. Okay, and if we draw one more line, if we draw one more line over here such that this is perpendicular to the line AB, this line, and say it cut it at point M, and let's join this line also. So one thing you can see that if O is the center of the circle, so OP is radius R and OA is also radius R. OA is also what? Radius R. And it is given that the ABCD is a square. So if AD is 6, we can also say that this length, like let this to be N point, NP will be also NP will be also 6 centimeter. So if this NP is 6 centimeter, NP is what? NO plus OP. NP is what? NO plus OP. And we know that OP is R. So will be equal to how much? NO is 6 minus R because OP is R. So we know that this distance is, like, I will do it, but wait. We have drawn this to be perpendicular, like we have constructed ON to be perpendicular to the side AD. So Okay, so this length NO is how much? This is 6 minus R. Now, if you see it carefully, then since the figure is symmetrically placed, like um, the circle is symmetrical to the square, you can also say one thing for sure, that this N will be bisecting AD. ON will be bisecting the line AD. So if it is bisecting it and it is given that AD is equal to 6, so we can say that AN is how much? AN is 3 basically. So if this is 3, you can see one thing over here. Let me point it out. This is our A, this is N, and this is O. A, AO is R, NO is 6 minus R, and this is given to be 3. So we can apply Pythagoras theorem. Applying Pythagoras theorem. So if we apply Pythagoras theorem, it says that R square is equal to 6 minus R square plus 3 square. So opening up the brackets, we will be getting 36 plus R square minus 12R plus 3 square 9. Okay. Now this R square will get cancelled. So 12R is equal to how much? 45. So from over here we get R is equal to 45 by 12, which is basically how much? 15 by 4. So radius that we are required is 15 by 4. But one thing that that how can we be very much sure about that ON will be bisecting the side AD? Like how can we say that it is not given in the question itself that the figure is symmetrically placed? So is there anything to support our answer, like that we can conclaim by that? So what we can do it, we can say that since AD is chord, we know that since AD is chord, so if AD is chord, ON which is perpendicular to the AD will be bisecting it. It is a property of circle. Let me write it over here. So what's the property? Property says that, sorry. So if this is the center of the circle and this is the chord, so the chord AB, if we draw a perpendicular line, a perpendicular from the center of the circle, and say this distance to be d. This is d is not equal to r obviously, because d is just this length, but r is this complete length. So d is not r. So here we can say that it is a property that this length AM will be equal to MB, right? So this is the property of the circle. You can also prove it by yourself. Like you can do some sort of construction, and if you need the proof of it, and if you want any help, you can comment down in the comment section. I will help you in the comment section itself. So I hope you have understood the question. The question was easy. It just require basic concepts, like some sort of symmetry kind of thing. And I hope you have understood the question and you have tried by yourself first. So hope to see you in the next video. Thank you. Till then, take care.